Now I've got something rather special. There's a large piece here in the museum from the Canyon Diabolo iron meteorite from Meteor Crater in Arizona, and this is one of the larger pieces. There's a lot of small pieces scattered all around, and here we have a larger piece. And initially, when it was discovered, people were thinking that there could be an iron mine because there were so many small flakes of iron floating around, and they even drilled into the crater, but they realized pretty quickly that there is no iron underneath the actual crater because the meteorite was actually kind of split into pieces, and it's around the crater and in the dust around the crater, and there were some larger lumps of iron, and here the resource is actually the material around the crater. So if we were thinking about mining on Moon or on Mars, then we would strictly be able to actually find meteorite craters from iron meteorite impacts and harvest the ejecta, the breccia material and the dust material around the crater if we find the right place. So let's have a look at this big chap here, and here it is, and it's really large, and I have to admit I find it really hard to lift it up. It's really dense, and density is something of 8 or up to 9 almost, I think. And here we have a metal phase again with a Wittmann-Stetten patterns, Kamacite and Taenite, the nickel poor and nickel rich iron alloys, and then we have the troilite here, that's iron sulfide, and the troilite is again very blobby, likely it was liquid, I guess, at the time, and this Wittmann-Stetten pattern is an exsolution again. So here we had crystalline material that was exsolving into a nickel-rich and a nickel-poor component. The lower part here has a little bit of, I guess I would call it an ugly cut, and this was actually done for research. So because the troilite here is standard for sulfur isotopes, and people wanted to get material, troilite material. So if we look at the lower side here, here we see a bit of the troilite that was cut here, and this was extracted for geochemical analysis. So this is how this cut here came about. So, and yeah, this is the kind of material we would be after. So either from the asteroid belt itself or in the ejecta around meteorite craters on the Moon, on Mars, or any other heavenly body we can get to. So this would be reasonably rich in nickel and cobalt, probably more enriched in those elements than most of the things we would find on the Earth's surface, and therefore financially this would be very attractive to get these high concentrates of nickel, chromium, and probably also platinum group elements in these iron meteorites.